Well, welcome to the final session of today in this technical track. And I will be talking about the HiPerGator infrastructure that is sort of at the really bottom foundation of the AI university model that University of Florida has created. So everything else that you hear about teaching, research, all of that relies on HiPerGator, which is managed by my team. And so we consider ourselves like a pit stop crew for our race car, which is HiPerGator. And that's why I have this shirt, which was designed by my staff. And I'm just showing how it all works. I will talk about the infrastructure. HiPerGator, of course, is a machine that you buy, and it costs, multiple zero kind of numbers. But there's more to it than just the machine. And actually, that's one of the messages that I want to convey. It's not enough to just buy the machine. You have the machine, and the size of the machine matters at some point. I will talk to you about that. But even more important is you need a lot of stuff happening around that. And what I'm showing in this timeline is we started in 2012. That's when we decided to build a data center. And then in 2013, we had HiPerGator first generation. And it had 16,000 CPU cores. At that time, there were no GPUs yet. I mean, the GPUs existed, but they were just for visualization and mostly for games and GPUs. NVIDIA was already a successful company, but not in the same way as it is now. Although that was already coming about, right? At that time, there was a growth, but we didn't start there. But some of the things that I want to point out is that there were some things that the university did as we developed our model. Is once we created a sustainable model in the sense that our hardware was not used for free and it was centrally operated. So the HiPerGator, in 2012, there were 80 little data centers and labs that had computers and clusters in them, and different faculty and different research group had little machines all over the place. And we started to build this central facility, and the university committed to hire some staff to try and support it. Like when we started in 2012, I was a part-time quarter FTE sort of director of the High Performance Computing Center, which is what it was called at that time. And we had 3 staff. One of them was a full-time staff, and the 2 others, I had to go and ask various deans for contributions so that I could pay the next 6 months of their salary. And that's when we started to actually get some more staff and build up the support, because we realized that if you don't have the staff, then the machine doesn't go very well used. And then there's another point. In 2017, our vice president for research made a policy that if you get startup funds from the University of Florida as a new faculty member, that money can only be used to contribute to the central infrastructure that we were building, and that he was funding with other funds together with the president and the provost. And you couldn't go build little centers, because our physical facility people had realized that if you have this data center in some building that has faculty and staff and students in it, it's much more expensive, because you have these chillers that have to be put there, they have special power maintenance, and after some years they need to be renovated, and it's all very expensive and it's very inefficient to have all these machines all over the place. And that actually helped, because we then had to convince our faculty that our central facility was 1, affordable, and 2, effective in supporting their research. And we also instituted another policy or a process where people could not use the machine. They could use it at no cost for teaching a class, but if they wanted to use it for research, they had to pay a subsidized cost. And that subsidized cost allowed us to actually build. And then by 2015, which is only 2 years into the 16,000 core HiPerGator 1, we had such a success adoption that we had to expand and got another 30,000 cores added to the system with HiPerGator second generation. And then we sort of kept on building, and by 2019 we were going for HiPerGator third generation. So the first generation HiPerGator was basically the CIO, Elias Alderi. He had money and he said, I'm going to buy it. We're going to build this the proper way. And then for HiPerGator's second generation in 2015, we hadn't generated enough funds to actually buy that expansion, but we went to the president and we said, look, we're building this, it's very successful, these are the metrics that we have, we need to make a further investment. And he actually committed $8 million to build HiPerGator second generation. By the time 2019, when we needed another $8 million for HiPerGator third generation, we had enough money in the bank from collecting the fees that we could just buy it. And that is when Chris Malakowski came and he said, hey, I want to give you a machine. So he gave us an extra big machine that augmented HiPerGator third generation, you know, way beyond what we already had. But that whole sustainability system was already there. And actually that is important to really get it going. Another thing that was very important at that time, when Chris Malakowski gave us this machine, he saw what we had built, and that proved to him that the chances that if he gave us a machine that we would be able to operate it and that our faculty would use it were pretty high, because we had been doing it for 7 years and the faculty had a great adoption. He could see that. So that gave him some sort of confidence that if he gave us this big donation, that it wouldn't go sit there unused. And then, of course, the 5 years after that, we actually, with a vengeance, sort of proved that, yes, we used it beyond his wildest imagination, which is why, as you can see, you know, and heard him this morning, he's pretty enthusiastic about what he did. And I think he should be proud of himself, and we are incredibly grateful. So this is another summary. Here is the HiPerGator team. Like we mentioned at various meetings already, I currently have about 34 people working on HiPerGator. But actually, that's just the people who work. There's like a third of them that deal with the hardware and the operating system, a third that provide basic support and maintain our 4,000 various software packages and Python modules and libraries and frameworks, and then another third that is AI consulting and advanced support. And we basically deal with the machine and the users, but then there's another team of 15 people that manage the data center that houses HiPerGator. And then we also rely on infrastructure, part of UFIT that manages the campus network, and all kinds of other software like authentication. And there is a business center that allows us, that does all the HR stuff and the payroll. And none of these people work for me, but I use their services. And that, I'm just, you know, sort of, it takes a village to make all this work. That's what I'm trying to point out. That's what I point out here. There's a whole bunch of things. And then we have very intense relationships with the provost's office on how to do teaching and learning. There's another division in IT that provides support for classrooms. They build out all the audiovisual materials in the classrooms. They have a team that help faculty build classes and video materials, and some of the people that are recording here are doing exactly that. All these people benefit the whole operation, and they are not really part of my team or the HiPerGator team, right? It's just, again, it takes a big group of people. So here's the overview. 2013 is the first machines we got in our data center. 2015, this is a piece of HiPerGator second generation. And in 2021, we put in HiPerGator third generation, which was fully funded by our sustainable business model, but it adds the donation from Chris Malakowski, which is the SuperPod that had the Ampere A100, which was the most advanced GPU system that NVIDIA built at the time, right? So you had 1,120 Ampere A100 GPUs, all connected with fiber optic, 10 miles of cable, so that every GPU could talk to every other GPU, and you could turn large language models. We actually trained one of the biggest large language models in 2021 before OpenAI built its ChatGPT. Ours was on medical terminology, and it's Gatortron. It's made available, and it was downloaded over the years 400,000 times by the research community because of its sort of innovative breakthrough capability as one of the first large language models. And then now in 2025, our board of trustees basically looked at what the university had done in the 5 years since 2021 with the donation from Chris Malachowski, and they said, we want to keep going there, and they funded buying the next generation, which is the current top of the line that NVIDIA makes, is the Blackwell 200 SuperPod. And our sustainability model funded, which I don't show a picture here of, a HiPerGator 4th generation, the CPU part and the low-end GPU part, and new storage infrastructure, 10 times faster, all flash, 12 petabytes, and another 30 petabytes of capacity storage. All of that was funded by our sustainability model, in addition to what the board of trustees funded to have HiPerGator 4th generation. And actually, that also from a sort of a political business, when you go to your leadership and you say, hey, we have $9 million to refresh the architecture of HiPerGator so that we can build HiPerGator 4th generation, but we don't have enough money to replace the SuperPod donation from Chris Malachowski. Can you fill it up with the necessary millions that we need? Now you have sort of a conversation. It's like, hey, I come with some money. I need a partner to do the rest. That's a much better conversation than when you say, hey, I have absolutely no money. I just want you to give me all the money. And that, that's sort of a general thing. So here is the new 4th generation HiPerGator. And it is a big success. We started it in operation in September of 25. And right now, it sort of hits 100% utilization almost every day. And the demand is just enormous. And that has grown over the years. We started training people in 21 on AI, and it sort of takes a time. And now, of course, with ChatGPT, everybody expects to use AI. There's just an enormous demand. Our faculty and our students have now been trained. We have opportunities so that they can learn how to use AI, think about AI, what it can and cannot do. And then their own brains come up with all kinds of ideas. I want to do this, I want to do this. And many of them have learned to do something on their own, but they still need lots of help. And so my staff needs to help them with our consulting efforts. And I've been authorized to hire more people as the need grows. So right now we're searching for new research software engineers and new research computing facilitators to help people get their work done. So to give you a little bit of an overview, HiPerGator infrastructure, we have a total of 200 nodes for the HiPerGator 4th part. So the left column is sort of the thing that goes with our sustainability plan that we can fund ourselves. We added 20,000 cores, and we have 600 NVIDIA L4 GPUs that have 24 gigabytes of RAM. And we have almost 12 petabytes of the brand new blue storage. And now in 20, they are already in production. And then in 26, there are 360 NVIDIA RTX 6000 Blackwell with 96 gigabytes of RAM that have been delivered. Half of them have been delivered. The other half will come a little bit later in April. And our 30 petabyte orange file system was also delivered and has now been powered up, and we are sort of stress testing it, and then we'll start migrating data. So that is the refresh of sort of the stuff that we can sustain ourselves. And then the NVIDIA Blackwell 200 was funded by our board of trustees to replace the donation from Chris Malachowski. And all of that is now running, and it shows that we need really multiple generations of GPU or multiple classes of GPUs. We have the L4 GPU that have 24 gigabytes of RAM. We'll have the RTX 6000 that have 96 gigabytes of RAM. And then we have the Blackwell 200s that each have 180 gigabytes of RAM. And not every application needs the full power, but we want our faculty and our students to be able to get their work done, and then we have to help them figure out what is the best for their problem. And so all of that is sort of a learning experience, but it's all part of what you have to get to train our people and to address the problems of all the people that we work with, which is faculty at the University of Florida. We're a land-grant university, so we have outreach offices in all 67 counties of the state, Florida. We also support faculty from all state universities and many public and smaller colleges in the state of Florida. And we also offer services to state agencies like the Florida Department of Health and Agriculture and Consumer Services and the Florida Department of Commerce. They're also using HiPerGator and our staff to help them do certain things. So all of that is the basic infrastructure that we provide. We don't do everything, but we do a lot. And then we have the, here to give you some more details that I already told you about the HiPerGator, the story from 2012, 2013, we had the beginning. And in 2015, we make this policy that people should not build their own data centers. And there were lots of faculty initially that sort of said, oh, no, because I've been working all my life and I've always managed my own cluster. I need full control and full details. But it turns out that managing a system, especially with the current cyber attack and cyber war infrastructure that we're in, is not that easy. You have to update your patches, and you can't just have a graduate student be a system administrator, because a system administrator is a full-time job, and if you have a full-time job of being a system administrator, you're not going to get your PhD done in time. So you have to sort of do the work differently. And in the beginning, faculty sort of didn't really trust that to happen. When we proved them that actually we are working with them and helping them, and it is more efficient, they sort of relaxed and they started to trust us. And the newer people that just come out of graduate school that we now hire as new faculty, they basically grew up as little kids with an iPad, and they know how the cloud works and whatever. And when we tell them, here, these are the services we have, they said, oh, cool, sign me up. I don't even want to do this myself. So another thing that happened on the side is that in 2015, we started to build a regulated research environment, and that forced us to learn in my team, as we were operating this special system, to be much more cognizant of security concerns and also how to deal with compliance requirements. So you have to realize there's a difference between operating a secure system and then doing all the things that a compliance framework asks you to do so that you can sort of manage the risk if you get attacked. I mean, when you talk about security, you can never make a system that is 100% secure except when you turn it off. If it's not running, then it's secure, and you can make sure that nobody does anything bad. If it's running, there's always something that can happen, and the worst thing, or one of the things that is sort of the easiest to understand, is that there's always insider threat. If you have some person who you have fully vetted and authorized, if they do something for whatever reason, that can turn into an adversary, and they sabotage your system or whatever. It does happen. So it's not if it'll happen, it's when. But then there's all kinds of stuff that you can do, and so we learned that, and then we slowly implemented these new, when the whole team became more cognizant, we became more mature, and we had several audits where the auditors interrogated almost everybody in my team over the years on how to deal with this one system. But then they sort of learned from that, and then they said, oh, when we make a change on this, let's do that a little bit more rigorous. So then when AI came around, especially the people in our College of Medicine, they were really excited about AI, but they had this concern that if they had to give up protected health information and had to de-identify all their data, then their AI models wouldn't be as accurate, and that you would have these algorithms that change your data to de-identify them, and then the AI algorithm would sort of try to come up with weird correlations that were introduced by the de-identification rather than really by the data that you're trying to study. So they really wanted us to have to give them the ability to use protected health information on this brand new beautiful machine that Chris Malkowski had given us. And that's when we decided to go with a high trust certification, again, an external auditor, to really make it possible for people to put protected health information on our system, and then they could run their AI model on the real raw data and be confident that it was the right thing. Actually, that's how we trained the Gatortron large language model. And all this stuff that we did since 2015 had prepared us so that when the high trust auditors came and they looked and they did sort of a readiness assessment of our processes and procedures, they worked on the summer of 22 and they came up in September with 87 findings. It's like there are 87 things that you are not doing correctly in order to get certified. And then we took 6 weeks in which we basically rectified all those and addressed all those findings. And we would never have been able to do that in 6 weeks if we hadn't been sort of prepared the 5 years before. And then they did the full assessment. So we did the 6 weeks. We started in September, and by mid-November we were done. And then they started the full assessment, and then by March 17 of 23, we were certified. And then we've been re-audited every year since, and we are still certified. And that is, again, something that we didn't anticipate, because we would say, well, we were just doing research and we're education, we're an open institution. Well, it turns out that now there are more and more things that require from the federal government to be compliant with certain frameworks. Like in January of 25, there's this requirement from NIH that says by January 25 of 2025, you have to, if you want to do genome sequence data sharing with the NIH, you have to meet NIST 800-171. So fortunately, we had this high trust certification, and you go and look at the 280 controls that the high trust certification checks you on, and you map them to the NIST 800-171 controls, and it turns out they're now all satisfied. So we basically had, okay, we can tell our vice president for research that yes, you can sign all the data use agreements with NIH because we meet NIST 800-171. So all of these things are things to be aware of, and the world is a more complicated place, and it takes a while to get there, but in the end, it is worth it. So here, I already told you about how we moved to this next stage by having our infrastructure prepared, and the donation from Chris Malkowski was he gave us a big machine, but it turns out that our data center didn't have enough power. We had a 1.6 megawatts data center, and most of it was being used by the infrastructure that we were running, and the machine he was giving us required a megawatt by itself. So the university put in $15 million to expand the data center power capacity from 1.6 megawatts to 3.2 megawatts. And that's something, a construction that we did during the 2020 COVID year, which was kind of challenging from a logistic point of view, but we actually managed to get it done. But that allowed us to actually work and get the HiPerGator 4th generation and the supercomputer from Chris Malkowski working in a timely manner. So then at the same time, as we heard, the university got some good graces from the state, and we got 100 faculty members to hire extra. And so then in 21, we basically deployed, so I got extra staff to, when the machine was available, we could develop training courses. We could help the faculty infuse AI in all their classes and in their teaching and train them, because many of the faculty, since we do it as a university-wide, obviously the sciences and the engineering people, you know, knew a little bit more about AI, and they also know how to program. But there's a lot of people that we wanted to be able to use the machine and do AI that are not naturally trained on AI or programming. So we developed courses, very fast, quick courses that people could take, and it was very successful. And we could actually see this during 21 and 22. We sort of had people working. We hired these 100 new faculty, which were distributed across all the colleges. And we trained them and got all the ones that were not necessarily AI by their own sort of education. We trained them. And then what happened in 23, which happened to be just after ChatGPT came out, all of a sudden, our faculty had taken enough training, they had understood it, and they had, you know, all kinds of insights, and they came to us and they say, I want to do this, I want to build this model, I have this problem, and I need an AI, and I need some help. And that's when we hired some more people to provide consulting and software engineering support for our faculty so that we could build with projects. And so now we have had a whole slew of projects, some small, some big, that have really made a difference in all kinds of things. So there are research projects that we work with, but also business processes at the university at various levels where AI has helped, and we have helped them develop and deploy like some small large language model or a RAG, something that is augmented based on the large language models that already exist. Sometimes we just do some deep learning. We've built several digital twins. So it's basically right now the entire university has been sort of sprinkled with all kinds of AI activities everywhere, impacting all kinds of activities across the curriculum and across the business operation of the university. And then there's some other lectures given across the across this conference about how we use and influence AI, but we keep building new infrastructure. I already told you about the HiPerGator 4th generation that we started preparing. So we just keep building more and more stuff. And then in 23, we made some more investments. And when ChatGPT came out, we were sort of ready. And that's when many universities across the country realized that AI was a thing. And so since then, we've been contacted by lots of universities to ask us, well, what did we do? What does it take to make it happen? To the point where the last year we had like 1,700 visits and tours from people who wanted to find out how University of Florida has been operating its infrastructure and sort of working with all of our faculty and students to make all this happen. With ChatGPT's announcement, there was immediately the need for coming up with some generative AI provisioning to the entire campus. And there we have the thanks to our creative team in AI. It's called the AI Platform Engineering Team. And they came up and built a infrastructure that is really a gateway. So instead of just the university picking one large language model, one of the famous ones, ChatGPT, Claude, or Gemini, we basically said, we'll build an infrastructure and we will make sure that people can go and pick whatever they want. And we will make also sure that the ChatGPT that they get access to through Navigator AI, that's the name of our gateway, that it runs inside the Microsoft Azure contract boundary, so that any data that people put there that is university data is not shared with OpenAI. And we have the same contract with AWS for Claude, and we have the same contract with Google for Gemini. And then any of the open source models we run on HiPerGator, which has been HITrust certified, so we can put restricted data there. And people can work with data, and there, of course, the cost is also minimal. But as part of the gateway, the engineering team also made sure that we keep track of all the tokens. Who is sending the tokens, and how much it costs. Initially, we're not charging people, but if the growth is to the point where we need to pay, then we know how to do it, and we can just say, hey, from now on, maybe we give you an initial credit, and then beyond that, you have to pay. There is another service that once we have that infrastructure, we've now built that infrastructure, and it has sort of grown quite significantly beyond just offering access to these large language models. Because what many people actually want to do is they have their own website that needs some AI in the background. And so they talk about data, or they present data, or they have an interaction with users. And then we basically contact the large language model, again of their choice, in the background with an API call, and we keep track of the tokens. Now those services we already ask people to pay for, and that has been successful. And the largest amount of tokens is like multiple million tokens a day are being used by the toolkit. And we also have extra support infrastructure built. For instance, if one of our students wants to say, hey, I want to have a conversation with a large language model, but I don't know which one is the best. And you can use maybe the ChatGPT OSS, the open source model that runs on HiPerGator, and I want to compare it to Claude and Gemini. Then you can basically say, hey, I want to talk to all three at the same time. If I type in one prompt, give me the answer of all three so that I can compare. And so that's something that, because we have the gateway, is possible for us to do. And it sort of helps people learn more about what is really different. Because people are creatures of habit. Like you try something, you have a conversation with ChatGPT, and you don't like the answer, you go to another one and you like the answer, and then you just keep using the one you like better, instead of saying, well, maybe there are some questions or some context where the conversation with Gemini is more effective, like, I don't know for what reason. And then also, the three big ones are constantly competing. Like in the fall, like last year, ChatGPT 5 was really great in the beginning of the year 2025. And then by October, Gemini and Google basically got sort of their hackles up, and they said, we need to work some harder. And they came out with a new Gemini that then beat the pants off ChatGPT. And then Claude came with its new thing in the beginning of the year, Claude Code, that was even better. So they are constantly sort of, like a race. Then one's leading, the other one's leading. And so for different topics, you need to be open and be able to change. And so that's what we provide to people. But then it's also true that we are supporting way more AI work than just access to large language models. So now the last thing that we just did is we created HiPerGator 4th generation upgrade, so we're all gung-ho about that. And we also created a workshop series once a month, and several documents that sort of document what we have done. And this one, the UF model guidance document, they're all available on our website, ai.ufl.edu. And if you want to come and visit us in this 1.5-day workshop, you can go to this ai.ufl.edu website. Under About, there is AI visits, and you can schedule and come visit us and learn more about how we do things. And that is all I have to say. Any questions?
Erik, can you just say maybe a word or two about how you deal with sort of the compliance review over a single system? Because you sort of, you have, as you mentioned, HiPerGator, but over it you have, various requirements from a compliance standpoint, from utterly open to ones that
Yes. So our design goal, when people asked about how do you deal with restricted data, our design goal was we have one system, and a lot of the work that we had done since we learned about compliance frameworks, we just sort of built into the background. It's like policies, documentation, configuration management, automation, all these things are totally invisible to our users. So when in 2022, we decided to go for the HITRUST certification, we had an initial meeting with the auditor that we selected through some bid process, and we said, look, what we want to do, and actually it was a conversation not only with the auditor, the certified auditor, but with the HITRUST people themselves, because I knew their vice president who was very interested in us doing this, because we were a research institution, which is not typically the kind of stuff that they do in HITRUST, because they just do hospitals and medical insurance companies and pharmaceutical companies. And so we told them, look, we have this system and it's being used by users for open data, and we don't want to put any hurdles in place that makes their work harder just to make it possible for the people who are authorized to work with protected health information to do it. So we had to come up with some ways to make this work. And they agreed. And so we went through our process, and basically what we do is all the technical stuff for the compliance and the logging and all that is all in the background. It's the system administrators that worry about this. And then the people who have to deal with protected health information, they have to go through some extra training, and they have to do some extra steps that make sure that their data is not visible to anybody else. And that allows us to allow this system that is used mostly by open users, and then by these smaller groups that have their own data. And then we have an even smaller enclave that has some extra technical controls for controlled unclassified information for defense export control work. So all of that is done on one system with multiple levels of rigor of protection and compliance.
So there's differential training depending on the data.
Yes.
But the same system is...
It's the same system. It's the same system, different training for the people. And my staff is, of course, trained and tested and vetted for the highest level of compliance. Yes?
If you look at the total computing needs of the University of Florida, are you able to make some kind of estimate of how much your data center contributes to that? Is it 100% or 75% or 50%?
Well, so there's two levels of so basically you have the enterprise computing, like the networking infrastructure. That's not part, that's just sort of basic foundation. And then there's a lot of computing that has to do with the business operation of the university, like our PeopleSoft for HR and enterprise reporting. And right now we're working to move that to Workday. All of that is independent. So that is, but when you look at it from a power consumption, that's not the biggest thing. It's like maybe 300 kilowatt, whereas HiPerGator uses a megawatt to run. So all the research and also the teaching of classes, like this semester we have 42 classes that are actively being taught with a total enrollment of 2,000 students. So they are using HiPerGator for their exercises, but it's a low load, but it needs to be available. And then we have a lot of research projects that are using the machine, and the machine is full all the time. We actually could easily use, we have about 1,500 GPUs right now, and we really would need to meet people's demand in a reasonable response time. We would need to have double that. So we don't have enough capacity for meeting that need of research and education.
question. Given that infrastructure that you have, does the Gainesville community have any pushback against the use of water, electricity?
Yeah. The use of water is a massive question of concern, and I have people, reporters from Tampa and from Gainesville and from Jacksonville that came and said, hey, we heard about this big stuff about data centers, but we have exactly the right answer, because our data center is cooled by a closed loop water. We don't use any water. As a matter of fact, just last Friday, we turned off one of the chillers because we are replacing it with a new one. It's from the 2012 data center, so it's 12 years old. And we looked at the meter that showed how much water it had pumped around, and it was 8 billion gallons since 2014. That's how much water, but it was a closed loop. It was always the same water and we filled that chiller loop in 2020 when we did the power upgrade, and we didn't use a single gallon extra since 2020. So we don't use any water, or, it's a closed loop. We fill it once and then it's done. So it's the right answer. We're not wasting. It costs a little more in energy. And actually that's why the story that all the data center builders are making, that they have to have the water, is not really true. They don't have to have the water. If they were willing to run their data center with closed loop water, it would be a little bit more expensive to them, so they would have less profit, but they would not be wasting the amount of water that we need for agriculture and people. So they would, we should actually force them, but they're not going to do it, but we should force them to behave like citizens instead of vultures.
Electricity?
Well, yeah, so HiPerGator, when it's running, it uses a megawatt, which is equivalent to, it takes about 5 kilowatts to run a house, so it's like 200 homes. All right then. Thank you. Oh, you have one.
Okay, so how to train the GPU program? Because the HiPerGator 3 and the HiPerGator 4 is completely different, right? So the AMD is the CPU base, and then DGX B200 is, of course, the GPU based supercomputers. So we need, we have to create the GPU programming, but also the multiple GPU program. How to train the program, that kind of the GPU program?
It's not an issue at all. I mean, because the HiPerGator, I talk about these multiple generations because that is sort of the technical details. But the system is operating all the time as one unified environment. There's just HiPerGator. To the users, there's just HiPerGator. And the reason we do that is so that we can actually teach these students and let them be as efficient in learning whatever it is they have to learn. They just use Open On Demand, which is a browser to connect to the machine. They start up the Jupyter notebook that the teacher and the TA have prepared for the class, and it just runs. They ask HiPerGator, I'm logging in, give me a resource, and it just works. Now, if there are advanced researchers who want to do some really sophisticated engineering study or a performance measure or train a large language model that's complicated, they go through extra training and they learn how to do all the complicated things. But we do not require that the beginners are that sophisticated before they can use it. Right? So that's why we designed HiPerGator as one unified thing. It took us a lot of effort to make that happen, and we just keep doing that same effort, but it pays back 100 times over because it makes it so easy to get people going, and that's the important thing.
Thank you.
Yes?
Thank you for the presentation. So I'm curious about the indicator analogy. So have you considered providing access to is this something special for you?
Well, no, actually, there will be, Nick Caesary tomorrow in this track will give a talk about Navigator AI. Everything that we use are just open source tools. So it's very easy to copy and do the same thing. We don't have sort of a simple website where you can download and make it work because it touches a lot of different pieces, but it's all open source and we are very happy to share anything to build it yourself. I mean, there's nothing weird, secret, or proprietary about it. Okay, thank you everybody.